Okay, so welcome back to another video. Here's a trigonometric integral from 0 to pi of sine square of x minus the square root of pi squared minus x squared, then dx. Some interesting thing we're going to do with this integral specifically is that we're actually, as you notice from the past videos that I've done several times, we've actually covered integrals where we actually do perform some u-substitution. Then it converts it to a different identity. Then we add its double. So we add the same integral twice after performing that substitution to actually help reduce down the problem a little easier to help evaluate the integral. So that's actually what we're going to plan to do here. But so in this situation, we're actually going to be using in terms of, a trigonometric substitution. We'll be doing it twice with two different substitutions that actually utilize the double of adding those two of the same integral itself to help reduce the problem a little easier to evaluate. So with that, that's kind of the big takeaway on how to actually tackle this integral. So why don't we actually just jump right in. So first, let's perform our first little u-sub. So I'll just call this x. So x equals pi times sine of theta. So that means I have that dx is then equal to pi cosine of theta d theta. Okay. And then afterwards, so we have our new bounds. So this is going to be 0 if we plug x for 0 and all that. And then next is going to be pi divided by 2 on the top. So then that just leaves us with sine square of pi times sine theta. Then if I plug pi times sine theta into here, that means pi squared minus pi squared sine squared theta. I can actually factor out the pi square for 1, but also take that square root of that, but that'll just leave with just pi. And then afterwards, we're going to have something in sorts of 1 minus cosine, or 1 minus sine squared theta. I gave the answer away. Oops. 1 minus sine squared theta, then that's going to be equal to cosine squared theta. Take the square root of that, so we get pi times cosine theta over here. Okay. And then now we just put in the substitution dx, so pi times cosine theta and then d theta. Okay, so let me actually reduce this down a little bit more. So first thing, I'll just factor out the pi from outside. So 0, pi divided by 2, then sine square of, so then it's just pi, then times sine theta minus cosine theta, and then just multiply with cosine theta over here, d theta. Okay, so now, the next step, we're going to do this in another similar fashion. So why don't we actually, now the second substitution in this case, we're going to let x, we're going to let that be equal to pi times cosine of theta. So then x equals pi times cosine of theta, then that means dx is then just equal to negative pi sine theta and then d theta. All right, now do the same thing again. Now, in this case, our bounds are going to be different. So 0 and then pi over 2, okay? And then now that's going to be sine square of, you can probably see where I'm going with this. This is going to be pi times cosine theta. Plug this back in, the same thing, situation holds, you do the same thing. So we get that this is just pi times sine theta after taking that square root of that. And then multiply with negative pi, then sine theta d theta. Then reduce this down more. So first thing is that the bounds are going to switch and then the negatives is just going to cancel. And I'll just factor out the pi from outside. So pi times 0 and then pi divided by 2. So that means, what is it? It's going to be sine square of, now multiply this by pi. I just factored that out. So then this is just going to be cosine of theta minus sine theta. And then close that off. And then sine theta then d theta. Okay, so now you're going to notice something different. So let's see, let me just label this number 1 and then number 2. What you're going to notice is that I thought you mentioned that we're actually going to build the double, so we're going to add two integrals up together, but it doesn't seem that way, right? Because we have, if you take a look, so sine square, cosine theta, we just did all this identity, but if you look at the input of the sine square, we have pi times sine theta minus cosine theta, and then pi times cosine theta minus sine theta, but you would think that the difference does matter, and meaning it doesn't mean they can't equal the same. However, sine square of an input, whatever, is actually an even function. So no matter what it is, you can actually just replace it by actually just switching it together. It doesn't matter the difference because again, it's an even function. So no matter what it is, you're still gonna get the same input. So we can actually rewrite this such that this is the same thing as writing as pi times sine minus cosine theta. And then this will eventually still be the same thing. So just to reiterate over here, same thing as pi sine theta and then minus cosine theta because it's an even function. So with that, now with that being out of the way, now let's actually add the two integrals together. So add number 1 and add number 2. So add, add 1 and 2. So then that just becomes, so I should have just set this capital I, so we'll just call that capital I. Use your imagination, just remember that. So 2 times capital I, so of course they're both the same thing, so pi, and then the integral from 0 to pi divided by 2 of sine square of pi times sine theta, and then minus cosine theta inclusive, and then next I'll just put sine theta plus cosine theta and then d theta. So as you can see, what we can do here is now let's actually use a nice little u-substitution. Yes, this is our third substitution of this video. So how many more do you think we're gonna do? Well, let's find out, watch to the end. So then let's actually call this t. So we'll let t equals sine theta minus cosine theta. So then that means dt is then equal to just cosine theta, and then add this with sine theta, then d theta. Okay, now that just reduces some things down. 2 times capital I is then equal to, so we have our integral, our new bound, so I should also write a pi out here. Let me fix that. So then we have pi times, so then our new bound in this case is gonna be -1 and then +1 of just sine square of pi and then times t, then replace this with dt. So actually notice that of course this is also an even function because of the sine square, we just mentioned that. So I can actually write this as 2 times pi multiplied from the integral from 0 to 1 of sine square of pi t and then dt. Okay, then we just replace the sine square identity to say that that's the same thing written as pi from 0 to 1. And also I just took one step ahead and just divide the 2 to both sides. So I'll just write this capital I over here. Pi times this integral over here from 0 to 1 of 1 minus cosine of 2 pi t, and then divide this by 2 dt. Then that just means that this is just going to be pi divided by 2. Then this input inside is going to be t, subtract sine of 2 pi t, and then divided by t. Evaluate this from your bounds from 0 to 1. And as you notice that you plug in 0, that's 0, 0, and then just plug in 1. So sine of 2 pi, of course, that's just going to be 0. So then therefore, I is then just simply just going to equal to just pi divided by 2. Just like that, reduces down to just a nice, simple answer after performing. So that was actually 3 substitutions that we did in this video. So there we have it. Everything nice and simple. Simple, I use the term loosely, depends on what your definition of that is. So with that, just like that. And yeah, that's pretty cool if you ask me.